These two homework problems in 410 should sound very familiar. They should be similar to the ones that we've practiced together in class. So our first problem, we have a storage tank along a road. Doesn't matter if your road is vertical or horizontal. So here's our storage. And we've got a home somewhere down the way here, 600 feet away down the road, and then 300 feet backward from the road. So here's the house. And we need to get a gas pipeline there. And it's cheaper if we would take the gas line along the road. So we could go all the way down the road and then do the two legs of that right triangle. Or we could spend more money per yard, but perhaps have a shorter distance if we did the pipeline directly to the house. Well, hopefully your instinct from our problem of swimming and running across the river might lead you to say, I bet we should build the pipeline part of the way down the road and then have the hypotenuse go over to the house. So to cover all of our bases here, we could pick either x for this distance and 600 minus x for this distance, or the other way around. So either way, we know that these two distances add up to 600. So our domain right away, our possibilities for x could go anywhere from 0 to 600. And our hypotenuse would be the amount of pipeline that is not against the road. And it looks like it would be a Pythagorean theorem. 300 squared is 9,000. And that would hold up even if x were 0. Even if x were our 0 value, then that should still work, because then the side of our hypotenuse would just be 300. So it would just be, the pipeline would just be that horizontal segment. All right, so let's see what we've got here for our cost function. We are going to have 600 minus x feet of pipeline along the road, and that pipeline has a cost of $8 per foot. And then we're going to have our hypotenuse, x squared plus 9,000 feet off the road, and that costs $10. So let's clean this up a little bit here. 4,800 minus 8x. And for purposes of differentiation, I might write this as an exponent. Whoops, 9,000 to the 1/2. All right, so let's find our critical numbers. Find our derivative. Derivative of 4,800 is 0. So we have -8, and here we've got a power rule. We'll bring down the 1/2. The 10 will become a 5. X squared plus 9,000 to the -1/2. And then times the chain rule would give us a 2x here. So we could rewrite this if you wish. And if we put that back into square root form, we want to find out when is that first derivative equal to 0. So if we're going to set that to 0, then we could move the 8 to the other side. We could multiply by the denominator. And I guess I keep adding a 0 there. We could square both sides. So 64 times x squared plus 9,000 and 100 x squared. And then we're going to have to distribute. So I'm going to move the 64x squared to the other side right away, if you don't mind. And 64 times 9,000, 576 with 4 zeros. And that divides by 36. So we get 16 160,000, I should say. And that's perfect square, so plus or minus 400. Now, remember our domain was only positive 0 to 600, so I'm going to ignore the negative 400 and I'm going to use only the critical number of 400 since it's the only one in the domain. And now I'm going to test the signs of the intervals of our C prime. So we only have one critical number, so let's find out what happens on the interval from 0 to 400 if we put in, and you could put it into this form right here. Think about putting in a number like 1, for example. So we would have a very small fraction here added to negative 8. So C prime of x is going to be negative. And then on the interval from 400 to 600, C prime of x, if we pick a number like 300, we can see that now the positive term is going to be larger than 8. So now our C prime will be greater than 0. So now we can say, since C only decreases and then only increases, we know that C has a local and global, if there is only one of them, local and global minimum of, and then let's come back and find that cost at x equals 400 feet. And we can remember that we want to plug that into our original function, not into our derivative. So grab your calculator, and indeed that turns out to be 6,600. So you had already seen the answer there, I hope. All right, so let's try again here. So we're building a rectangular corral and dividing it right down the middle. So you could pick x for this length, but then you'd have to go with 1/2 x for each of these. So why not choose your variables differently and say let that side be 2x? So then these pieces would just be 1x. So it really doesn't matter which length that you choose there, and we really don't care about that area. So whether you call that x or 2x, and I think on my solution key I called it 2x. So we might try this differently and say that that's x. And then these lengths are y's. All right, so in this problem it seems like we're given some information we don't need. That is that the area is equal to 1,300. So the area, x times y, would give us 1,300. Maybe write this, and that might be useful to us for substitution into our cost function. So the cost of the fence, here's an interesting notation we maybe haven't used much. The cost function here is a function of both x and y. So the perimeter fence, that would be 2x plus 2y. The entire perimeter costs $5 a yard. And this middle piece here, which is y yards long, only costs $3 per yard. So let's clean up our cost function here. We've got 10x and 13y. And this is where we could make the derivative easier, and we could say, well, why don't we get rid of one or the other of them? So if I solve this for x, 1,300 over y, then I could replace here. So you don't have to necessarily do this, but now I've got our cost function only in terms of y. So it would be 13,000 y to the negative 1 plus 13y. And now we can find the first derivatives so that we can find the critical numbers. So by the power rule, And then we want to set that to 0. So let me write this so you notice that denominator. If I move that negative term to the positive to the other side, it will be positive. And then I can move the y squared by multiplication and divide by 13. So our y looks like it will be a 10 radical 10. Now, why didn't I put plus minus there? The algebra, of course, should be plus minus. But notice that for the real problem here, our y would have to be bigger than 0. And for our area, remember that our constraint on y is that y is definitely going to have to be less than our 1300 value. So we know that it is going to have an upper bound. So you could think of your value here for your y coordinate. And we're only going to use here the positive as our critical number. Use the critical number of 10 radical 10 for y. So now let's test our intervals on 0 to 10 radical 10. And then what happens if we're larger than 10 radical 10? And we could go all the way up to, say 1300 divided by 3. You might say, well, what am I thinking there? Well, you could get an area of 1300 if you did a ridiculously large value of y, but you'd still have to come up with an area of 1300. So let's leave that there and test our interval. So our C prime, if we picked a value, so I'm looking at our value of C prime. If we choose a number like 1, think about putting a 1 in there. This number is negative here, so we'd have a positive. Sorry, I think I said that backwards. That would be a negative. And if we pick a number larger than 10 radical 10 and try it in there, we'll get a value that is positive. So since C of xy only, well, and I guess I'm just using y at this point, doesn't make much difference, only decreases and then only increases, C has a local and a global minimum. If it's the only one, it's got to be the lowest value of, and then we can find our value. Oh, and actually we don't have to. It doesn't ask us for the minimum cost. It just says what should x and y be. So it has a global and local minimum when y is equal to 10 radical 10, and it's in yards, not feet. And then we can go back and do our substitution. Remember what we had here? So our x value is 1300 divided by y. So 1300, our x value is 1300 divided by our y value. So we could divide by 10, and you need not rationalize. You could leave it that way. But in case you see it rationalized, 130 radical 10 over 10. So you might see it written as 13 radical 10 yards. And that should do it.